Hello friends, I am SK your tech tutor and welcome to my YouTube channel TechTuber once again. And this is a new video on Arduino. Today I will show you how to make a line follower robot using Arduino Uno. So for that you need a chassis, two BO motors, and this is called custard wheel. This is a custard wheel, and the essential part, the sensor. This is you need a IR sensor array. You can use single IR sensor, or this is your microcontroller or Arduino, you can say Arduino Uno. This is the main board, and again you need a motor driver IC for driving this 12-volt motors. As the Arduino output is 5 volt, you need a motor driver IC here. So this is your motor driver IC L298. So this is your motor driver IC, and you can use battery for power supply. 9-volt batteries, two 9-volt battery will be sufficient, for one for this motor driver IC and another for this Arduino. And otherwise you can use this giant adapter. It's a 12-volt 2 ampere adapter. It will work fine with your motor driver IC. You need to connect directly with your motor driver IC, and you need some wires and some jumper wires as well, and female DC jack. So let's start to make this project. So at first I will describe one by one how we are using and why we are using these components. So let's start with the chassis first. So let me put the other thing aside. So these things are, so now this is your chassis. Why? So this is a chassis, it's easily available. How you will make this chassis for your project, perfect for your project, I can say. So this is two BO motors, 150 rpm BO motors I am using. You can use more than 150 rpm or less than 150 rpm. So you need to attach BO motors and the wheels, and this is your custard wheel. It has a universal direction of rotation, so you need not to add or again two wheels. So this is a bedding for the sensor. Actually the sensor is large in size, so you need a bedding. There is no dedicated slot for the sensor, so that's why you need to make a bedding for the sensor. You can make it by wooden, or by steel plates. So this is the sensor. Now coming to the sensor, so this is, you can see the closer look of the sensor. It has IR sensor, 8 IR sensor, which emits IRs and receive the IR sensor, reflected IR sensor. The basic principle behind making a line follower is which follows a particular color. So that means you need to adjust the sensitivity. That I will come that part on later. So this is your IR sensor, which let me assume you have a line on a black line on a white surface. So that means all the IR will be absorbed on the black lines, and it will not reflect any of the light. So that's why there no reflection will received by the IR receiver, and there will no signal. That means it will give you 0. If you consider digital pins, it will give you 0, and if it's a white surface, it will give you an output, and it will receive the reflected IR sensor. That's why it will give you output, a voltage, that is your 1 signal. So that means it's giving you 5 volt or less than some 5 volt. So the basic principle is this. And so this is your IR sensor, and again it's a L298 motor driver IC. So motor driver is generally, we need motor driver because the Arduino, so let's discuss Arduino. So if you use Arduino, it gives you a logic signal, that means plus 5 volt. So this plus 5 volt is not suitable to run this BO motors, as this is a 12-volt motors. It will run comfortably on 9 volts also, but you need at least 8, 9 or 10, 12 volt. So for that you have to step up, or you have to give external power supply. So this is why we are using motor driver IC. We are connecting a line from the data line from the Arduino output and on these motor drivers, and the motor driver will put additional power which will be connected over our 12-volt power supply, external power supply or a battery, and it will give the sufficient power for the motors whenever you will give a signal. So this is motor driver IC. It's actually working like a relay. So you can use 9-volt battery to power up this motor driver IC. So jumper cables and the cables you need, and the female jack you need because you have to connect the motor driver IC with the adapter, 12-volt adapter. So let's connect and let's see how to connect. So coming to the connection part, you need to understand the Arduino board at first. So the Arduino board has a microcontroller. This is the microcontroller chip. This is your clock, and this is the external power supply port. This is your programming port. This is your reset button, and these rails are for input output and the power outputs. So you can see here, so it has some pin outs, female pin outs, and this is your input output pins for digital output and inputs. It's dedicated digital output and input pins for this microcontroller board, and it's also available PWM. If you don't know what is PWM, you can search on my video list. There is available on a video is available on PWM. So it has RX and TX. I think if you are a beginner, you don't know what is RX and TX. It's a communication ports. So I will discuss, or I will make a new video on that later. So coming to the other part of the input output pins, you can see these are this 5 or 6 pins is analog pin. So you can see the analog pins are there, and the digital pins are there for output input. You can one thing you remember that you can use analog pins as a digital input also. For that you need to understand what is analog, what is digital. So you will understand later. I will make some videos on this later. So these are the power rails. You can see here you have V in, external power in. You have ground, 2 grounds, and 5-volt power output. You can take 5-volt power output for any sensor from this Arduino board itself, and you have 3.3 volts. Some of the sensors have 3.3 volt pins. You need to use that 3.3 volt pins from Arduino, and so on. So this is your main things. This is the main pins you need to understand here. So let's connect for this sensor. If you want to connect this type of single sensors in a like a array external part, it will add some bulkiness, because each and every sensor will take power. For that you need to give dedicated wires and data wires. So each and every sensor will take 3 wires. So if you want to connect 8 sensor like this single, so it will take, that means 3 into 8, 24 wires. But on the other hand, if you use this sensor array, it will reduce the bulkiness. It has the output pins and the parallel outputs for each sensor. It has 8 digital pins, and from the left you can see sensor 1 is written here, you can see, and for that means this is the pin for this sensor. For this first sensor, from the left side you have S1, S2, S3, S4 and S8 respectively. So these pins are from the left side, and count it for each and every lines. So you will just add 8 lines and put it here, each and every 8 wire, put it here one by one. You can use any 8 pins of digital side, and you have to give the VCC and ground. For VCC and ground you have to use 5-volt power supply from Arduino, which is here. This is your 5-volt power supply, and the ground will be connected to the ground. And now let's see the connection. After connecting, you will see how it looks. So this is the connection for the sensor. So let's discuss it. So you can see here I have connected the sensor, 8 outputs of the sensor, S1, S2, S3 and S8 till the S8. Each and every connection is directly connected with the Arduino board. You can see here is the 8 pins, and the respective pins are connected on the Arduino board from 0 to 7. That means we are connecting 0 to 7 each and every pins respectively for S1, S2, S3, S4 and S8. So these are the connection. This is the parallel connection. See closer look. So from S1 to S8 you will connect 0 to 7 on this respectively, one by one. And for the power, this is your VCC pin and is connected with your 5-volt power supply, and the ground is connected with your ground on Arduino. So this is the connection for the IR sensor here. And now I will connect the outputs. These are the input parts. You will give it, the bot will take the data from this sensor, and the data will be transferred to the Arduino for further processing, and the Arduino will receive the data. The each and every data from the each and every sensor will be received by these pins 0 to 7, and then it will process something which you will program. And one thing you note down, that while you will program this, you need to define these pins. That means where the S1 is connected. For example, here S1 is connected with pin number 0 of digital pins. You have to define the pin where the S1 is connected, where S2 is connected, and this is how it will go. So now connect the power supplies or the outputs for the motors, for the two motors. So before connecting the motors or the outputs from the Arduino, let me discuss the motor driver IC here. It's a L298 motor driver IC, and you have to give the external power supply on these pins, these two pins, and the third pin is for your 5V out. You can use this 5V out, and the ground is common. And the two motors output will be this one for the left side, let's say for left side motors this one, and for the right side motors this one. So these two, one for the output, 12V outputs for two motors, and you will give the signals for the motors on these 4 pins. You can see here closely, it has a 4 pin outs. So let me connect this IC with the Arduino, and then I will discuss a circuit on the paper so that you can understand the motor driver function. So let's understand the very clear concept of the connections. So this is your Arduino, and the sensor part, you know that the sensor is connected, and the main part here is motor driver IC. For motor driver IC, you have 4 outputs from the Arduino. So for this motor, you have 2 pins of pin outs, and for this motor you have 2 pin outs, because a motor can rotate on the both way. So that's why you need to give the different signals to rotate on the both direction. So let's assume our table here. This is motor left, this is motor right, and consider this is pin number 1 and this is pin number 2. It can be any pin of your Arduino. Let's assume that this is one pin of this motor, and this is the another pin of this motor, and same for this part. I will not discuss this part. Let's discuss the motor one. So 0 0, if you program in such a way that you give 0 0 on the both pin of the motor, or you can see on the motor driver IC here 1 and 2, if you give both the pins 0 and 0, the motor will not rotate because there is no signal of rotation. If you give 0 and 1, the motor will start rotating in a particular direction. If you give 1 and 0, exactly the reverse, it will rotate clockwise. If it is rotating clockwise, then it will rotate anti-clockwise. That means the opposite rotation. And if you again give 1 and 1, it will not rotate because both the pins are high. So it will in stop condition. Same for this motor right side. So this is the logical part here. The motor driver IC is doing nothing. It is just adding the external power of 12 volt on the motor, and the logic part is same. If you apply this logic part via the wires of this motor or the motor driver IC which is connected with your Arduino for a particular motor, so it will give these outputs of this or these rotations as your desire. So I think it's clear now, and let me show you again. So this is your entire connection. There is nothing left here. You have to just put the setup in this chassis, and you have to program the Arduino. So before closing the circuit part, I will show you after attaching. And before that, you can see I have connected 8, 9, 10 and 11 of the Arduino on the motor driver IC. So you can assume that 8 and 9 is for motor 1 or the left side motor, and 10 or 11 for the right side motor. You can choose any type of motor, but you have to define on the code that which pin you are using for a particular motor. You can say which pins. That means you have to use 2 pins for a motor because you need the both way rotation. So this is the entire circuit part. It's very easy. Now I will discuss the code. Before that, I will show you after attaching the parts. And these are the motor outs from the chassis. These are the motor wires, both the motor wires. You have to add these wires like this one here and this one here. You need not to worry about the polarity. So after putting all the parts into the chassis, it will look like this, and the sensor will detect the line, any line, black or white line on a different surface. This sensor will detect and it will go further. And one thing I forgot to say about this motor driver IC, which is you can see here, you will find that in 1, in 2, in 3 and in 4 for the 4 output from the Arduinos on the motor driver IC. That means the motor driver IC is taking the signals from the Arduino, and respectively you will find the output pins here: out 1, out 2, out 3 and out 4. That means if you give a data in 1 pin, that data will be out from this pin. So this in 1 and out 1 is correlated, this in 2 and out 2 is correlated. That means if you take a particular motor side, that means in this side, on the right side, in 1 and in out 1 and out 2 is connected with this motor. That means for any signal if you want to give on this motor, you have to give on in 1 and in 2 motor. So this is a basic assumption you can say if you are programming a motor motor on Arduino. So let's check the programming part on the laptop.
So coming to the coding section, you have to install Arduino IDE in your laptop or computer. So for that you need to open arduino.cc from Google, and their website, it's open source, it's free to use, free to download. And from there you have to go software, and then scroll down and you will get the download links for your proper OS, and click on download installer in the Windows installer and download the file. It's a 185 MB file, and install in your laptop. And then from there you need to open software and scroll down. You will get the links for the download, and click on the Windows installer if you have Windows system, and you will get a 185 MB file, and then install in your laptop or your computer, and you will get arduino.cc Arduino IDE software, and there you have to write the code. So coming to the Arduino software, you will get this type of page, a blank page where void setup and void loop is written, and on this page we have to write the program. And void setup is for your defining the pins which you are using for your project on Arduino. You have to define all that pins on void setup section, and on the void loop section you have to write the exact code, what you want to do, what are the tasks you want to do in repeatedly. So you have to write the main code in the loop section and the setup section for defining the pins and other work. So let's discuss the sample code of your Arduino line follower robot. So this is a sample code, and here you can see you have some variable, integer type variable on the names of each sensors, S1, S2, S3, S4. These are the variables which is stored, the 0 is stored here. So the 0 because we wanna get the exact value. We don't want any garbage value from that variables. Actually these variables are storing the data from the sensor, 8 sensor. On that 8 sensors the data are coming and storing on that 8 variables, S1 to S8. And the constant part here, constant integer variable left motor. So that means left motor equals to 8. That means you are defining the pins where the left motor is connected, left motor, right motor and all. So left motor forward, left motor backward. That means you have 2 pins for a motor, so that's why you will use 2 pins. And here you can see the pin mode in the void setup section. It's very important. In void setup section you have to define the pins. For that you have a function that is pin mode. You have to write pin mode. So this is your pin mode declaration. What the pins, what is the pin name and what purpose you are using, what is the purpose. So that means, for example, I am using 0 to 7 pins of digital pins of Arduino for input output purpose of input output signal of from the sensor. So that's why I am using 0 pin mode 0 comma input. So the Arduino is taking the inputs of the values of sensors from pin number 0 to 7 respectively for sensor 1, sensor 2 and sensor till the sensor 8. So for that the function is pin mode 0 comma input, pin mode 1 comma input, these lines. Now coming to the next pin modes declaration, and remember one thing, always the M is capital, the second half of this function is capital, first letter is capital. So pin mode LMF output, that means these are the code for our motor outputs, and you are defining that these pins are output pins, these pins are input pins. And serial begin is for the serial communication between the Arduino and the sensor, and this communication you can see from here, the serial monitor. To see these sensor values, you have to open serial monitor. The sensor, whatever the value the sensor is returning to the Arduino, you can see from this serial monitor. For that you have to write some code, extra code. So coming to the void loop section, you can see here S1 is storing the value on the pin number 0. That means the pin number 0 is the first sensor. Sensor number 1 is connected on the digital pin 0 on Arduino, and that value we are storing that value, whatever the sensor number 1 is giving, that value on S1 variable, which is declared here at the first. So it's an integer, and that value is storing for same for the sensor 2, sensor 3, sensor 4 and sensor 8. Each of the value from the sensors which is actually coming on the pins of 1, 2, 3 and till the 7, it is storing on S2, S3, S4 till the S8. Now coming to the serial print, this is very important. If you want to see that result, see that values in the serial monitor here, you have to write this code serial.print S1. That means whatever the value S1 is holding, you wanna see, that's why you are writing serial.print S1. So that is one thing. And coming to the very important part, that is loop part, that is your program, exact program. So the logic is, if S4 and S5, that means the middle two middle sensors are if these two middle sensors are giving 0, that means the black line is there. So if two middle sensors are giving 0, you have to follow that line. That means you have to go forward. So that is the code for going forward. Digital write, if you wanna give some output, that at that time you have to write digital write. If you wanna read some values from any sensor, you have to write digital read, like here. And for output you have to write digital write. So digital write, RMF high, RMB low, and these are the motor outputs. These are the output code for going forward. And you have a delay. Delay is used for a little gap between every processing. So you are free to use delay. It's in milliseconds unit. That means you are using a 10 millisecond delay so that the microcontroller works properly. And then if sensor number 6 equals to 0, or sensor number 7 equals to 0, or sensor number 8 equals to 0, that means if any of this sensor is giving 0, that means any of this sensor is detecting black, that means the sensor 6, 7 and 8 is present on the right side of the board. So you can assume that the black line is on the right side, as these sensors are detecting 0 or black. so you have to move on the right side. So for that, this is your code, digital write RMF low. That means you are giving the low signal for the right side. As you know that if you want to move right side, you have to stop your right side motor and active your left side motor. So this is the code for moving right side. And for the left side, it's same. This is the same logic. We are using same logic. And one thing you must remember, that this logical function under if, this logical condition, you can say, it may be various types of condition. You can add lots of condition here. I'm just giving an example. This is a simple one condition. You can use any type of operator, that means and or not. We are using or. You can use and operator. You can use any operator, any logical operator, and you can write this code. So this is example, simple example. And one thing I must before closing the software part, you will get some type of problems while you are coding. If you forget to do these things, if you forget to add these semicolons, you will face some problem on compiling the code. And if you want to verify your code whether it is right or wrong, if there is a logical problem or some code problem, line syntax problems, for that you can verify from it clicking this button. And if you want to save this, if you need to click on this. And if you want to upload the program, for that you have to click on the upload button. And before uploading the code, you must assure that your port is selected. If here nothing is selected, because there is no Arduino connected with the laptop. If you connect Arduino with your laptop, you will get some port option. You have to select that port. And one thing, you have to select Arduino Uno port. Arduino has many of the products, so you need to select the Uno if you are using Uno. If you are using Leonardo, if you are using Mega, you have to select on that case. So this is all. And so this is all from the coding section. Let's see the actual working video, how it's following the line.